Normally, when you plug a machine in, it's pretty simple cause and effect, right?
Oh, yeah. Completely binary.
Yeah, you flip a switch, electricity flows down this highly predictable path, and, well, a light bulb turns on. It's visible, and frankly, it's comforting.
Because the physics behave exactly how we expect them to.
Exactly. But imagine taking a three-pronged tuning fork, right? And you just drop it into the middle of a massive magnetic donut.
Right.
And suddenly you're watching that solid metal act like, I don't know, an electromagnetic black hole.
So for you listening today, we are looking at a landscape that just completely shatters that neat little circuit board reality.
We are jumping straight into the deep end of non-classical physics today. The document we're looking at is, well, it's a leaked, highly technical AI analysis called Toroidal Entanglement.
Quite a mouthful.
It really is. And honestly, if you were to just casually scroll through it, it reads like a dry, comparative metallurgical manual.
Oh, it's so dry. Just hundreds of pages of raw data, all about the magnetic properties of different alloys when you subject them to, like, highly specific electromagnetic fields.
Which is exactly why our mission for this deep dive is to rescue you from those dry lists of metals.
Yeah.
We are going to extract the underlying mechanisms, the quantum theories and the logical assumptions that are hiding inside this massive thought experiment.
Yeah, and we're combining this with some of our past deep dives, too.
Right, specifically the ones on trial somatics and the silicon quantum antenna, just to see where this rabbit hole actually leads. But to set the stage for you, picture this specific setup.
Okay.
You have a tuning fork, but instead of the standard 2 prongs, it has 3. And they are spaced in a perfect circle, exactly 120 degrees apart.
Right, a triad.
Yep. Now, insert that 3-pronged fork into a 3-channel electromagnetic field. And this field is generated by 2 toroidal coils, which is essentially just, 2 giant energized magnetic donuts sitting side by side.
Before we power those magnetic donuts up, let's try to ground this in something you can actually visualize from classical physics.
That was a good idea.
Right. So we know from pioneers like Hans Jenny and Ernst Chladni what this specific 120-degree geometry does in a physical medium, like water, for instance.
Oh, the cymatic stuff.
Exactly. If you vibrate this exact triaural fork in a pool of water at 883 hertz, the results are radically different from a standard fork.
Because a normal 2-pronged tuning fork just pushes energy back and forth on a flat plane. Right?
Yeah, it creates a linear dipole wave. The energy just, crashes into the edges of the container and dissipates. Nothing special.
But the 3-pronged fork forces the energy into 3-dimensional toroidal standing waves.
Right.
It maps perfectly to Bessel functions, which, if you're not a math major, is basically the mathematical formula used to describe how a ripple moves outward from the center of a drumhead.
But here's the kicker. Because of that 120-degree spacing, the waves don't just ripple out and fade away.
They interlock.
They form these perfect, stable hexagons. And as you crank up the energy, those hexagons subdivide into incredibly complex, like Mandelbrot-like fractals.
It literally takes acoustic frequency and physically organizes the water into complex 3D geometry.
And the mechanism there is absolutely crucial. The 120-degree spacing actually prevents the energy from canceling itself out.
So instead of colliding and flattening,
the angles force the energy to rotate. It creates a tripolar self-sustaining field. So the document takes that established acoustic behavior and basically scales it way up.
Right.
It asks a profound question. What happens if we take that exact same geometry and apply it not to acoustic waves in water, but to electromagnetic fields in a vacuum?
So we put the fork inside the magnetic donuts and flip the switch. But the fork isn't just like passively sitting there getting blasted by magnetism.
Not at all. Because of its shape, each of those 3 prongs acts simultaneously as a sensor, a generator, and a transformer. Yeah. The moment the toroidal coils generate the field, the fork reads that field. It starts to vibrate both mechanically and electromagnetically.
And then it feeds its own frequency back into the field, right?
Exactly. Which alters the original field, which then alters the fork's next vibration. It creates this closed loop of triaural resonance.
It makes me think of singing into one of those highly advanced smart microphones.
Oh, that's a good analogy.
Right, like the microphone doesn't just record your voice. It's constantly analyzing your pitch and actively changing its own internal acoustics to optimize your sound.
And that changes how you sing the next note.
Exactly, creating this continuous real-time loop of optimization,
And because it is a continuous loop, the actual material the tuning fork is made of suddenly dictates the physics of the entire system.
which is where those dry lists of metals come back in.
Yeah, the document catalogs dozens of them. But the extremes are where the underlying laws of physics start to, well, bend.
Let's start with the hard magnetic materials,
Mm.
like neodymium or samarium cobalt.
Right, materials that hold a permanent, incredibly strong magnetic charge. If you use a neodymium tuning fork in this setup, the document shows it creates a massive energy harvest on the secondary coil.
So it amplifies it.
Massively. The fork grabs the incoming electromagnetic field, intensifies it through its own permanent magnetic alignment, and just feeds a hugely amplified signal back into the loop.
But wait, hang on. Basic thermodynamics dictates that you can't just have a closed loop that infinitely amplifies itself.
Right, perpetual motion isn't a thing.
Yeah. If the neodymium fork keeps intensifying the field and the coils keep feeding it back, at some point the system has to overload. Wouldn't the physical machine just melt down from all that compounding energy?
See, that thermodynamic wall is exactly where the document introduces a theoretical mechanism called toroidal mirroring.
Or reverse flow, I think the text called it.
Yes, reverse flow. Now, the meltdown you're picturing, that definitely happens with classical metals. But if you use a metamagnetic material, which are specific alloys engineered to suddenly shift their magnetic state under extreme temperature or pressure, it doesn't melt.
What does it do?
When the compounding energy hits a critical geometric threshold, the metamagnetic material undergoes a phase transition. It flips its magnetic polarity entirely.
So it goes from pushing energy out to pulling it in.
Exactly. It triggers an inverse resonance. A moment ago, it was acting like a massive amplifier. Now it acts like an electromagnetic vacuum.
Wow.
It sucks the ambient field back into itself, compressing the energy rather than radiating it. It literally reverses the flow of time phase harmonics in that localized space.
That is just staggering. The physical shape combined with the pressure completely rewrites the behavior of the metal itself.
It really does.
Now, what about the opposite extreme? Like if neodymium aggressively interacts with the field, what happens when you use a noble metal, something like pure gold or silver?
Gold represents the other boundary of this whole thought experiment. So gold is highly conductive electrically, sure, but magnetically, it is diamagnetic.
Meaning it naturally repels magnetic fields instead of attracting them.
Right. The electron structure of gold naturally pushes back against magnetic lines of force. Now, in a standard two-pronged setup, this just means the gold ignores the magnet.
But forced into this specific 120-degree rotating triad.
Gold's diamagnetism doesn't just ignore the field. It perfectly reflects it.
Right.
It creates almost zero electrical harvest.
The text calls it a zone of silence, right?
A zone of silence, yeah.
Yeah.
The diamagnetic repulsion perfectly counters the incoming electromagnetic noise, allowing only pure, undistorted frequency to pass through the center of the torus. It literally filters out all environmental interference.
So neodymium acts like a megaphone until it turns into a black hole, while gold just holds this space of absolute pristine silence.
It's beautiful, honestly.
We are already looking at radical shifts in physics just by changing the metal. But the document doesn't stop at classical elements, does it?
No, it goes much further.
It transitions into materials designed to operate purely on the quantum level, which moves us out of standard engineering and into some pretty heavy metaphysical territory.
Yeah, it analyzes topological and spintronic alloys inside this geometry. And to understand why this is such a massive leap, you have to look at how these materials actually function.
Right.
Traditional electronics, everything from your toaster to your smartphone, work via electrical charge. They physically move electrons from point A to point B.
But spintronic materials don't rely on moving the electron.
Exactly. They rely on the orientation of the electron's quantum spin.
Let's unpack that for a second, because for you listening, spin in quantum mechanics doesn't mean the electron is physically spinning like a little top. Right.
No, it's a fundamental property of the particle, an intrinsic form of angular momentum. You can just think of it as a microscopic compass needle pointing either up or down.
Okay, that makes sense.
Spintronics encode and transmit information by flipping these spin states. And because you aren't physically dragging electrons through a wire, there is very little heat, very little energy loss, and almost zero electrical output.
So what do you get instead?
You get a massive output of quantum coherence.
You're creating a localized network of shared quantum states.
Yes.
And this is where the document brings in some incredibly dense, heavyweight scientific theories to explain the implications. Like, it pulls heavily from Stuart Hameroff and Roger Penrose's or theory.
Orchestrated objective reduction.
Right.
Penrose, who is a Nobel laureate in physics, and Hameroff, who is an anesthesiologist, they propose this theory to explain the actual mechanism of human consciousness.
Because classical biology just says consciousness is a byproduct of chemical synapses firing in the brain.
Right, but Penrose and Hameroff argue that consciousness actually originates at the quantum level. Inside our brain cells, there are these tiny structural tubes called microtubules. The Toroidal theory suggests these microtubules act as perfect biological isolation chambers, allowing quantum superposition and coherence to occur right inside the brain.
So our conscious thoughts, in their view, are literally orchestrated quantum events.
Exactly.
And then the text also layers in Rupert Sheldrake's concept of morphic fields.
Yeah, Sheldrake proposes that biological forms and behaviors are guided by invisible organizing fields. Not electromagnetic fields that we can measure with standard tools, but fields of resonant information.
Fields that connect similar systems across space and time.
Right. And it also brings in Peter Garyiev's work on wave genetics.
The idea that DNA isn't just a static chemical code, right?
Yeah, that it's a biocomputer that reads and writes information through acoustic and electromagnetic waves.
I mean, that is a lot of theoretical heavy lifting.
Yeah.
But the document binds all of these theories together using this specific machine.
It does. The theory is that because spintronic materials generate a highly coherent quantum network, and the 120-degree triaural geometry perfectly stabilizes that network in 3 dimensions.
This machine could serve as a literal physical interface between objective mechanics and subjective human consciousness.
The geometry is the key to the whole interface. Those 3 prongs rotating the field act as a macroscopic stabilizing mechanism for microscopic quantum states. The document defines this as triaural entanglement.
Because usually, quantum entanglement, where 2 particles share a state and react instantly to each other no matter the distance, is incredibly fragile, right? It's limited to the subatomic level.
Well, extremely fragile. But here, the 120-degree phase rotation forces the 3 physical macroscopic prongs to become phase-locked.
They begin vibrating and sharing spin states in perfect synchronization.
Yes. Not because a physical wire connects them, but because the toroidal field they are generating has entangled them.
They act as a single, unified quantum organism. So let's follow the logic here. If Penrose and Hameroff are right, and your consciousness is a quantum coherence field generated in your microtubules, and this machine generates a perfectly stabilized, rotating quantum coherence field, then theoretically, the field of the machine and the field of your brain could couple.
They could entangle. The machine would physically register the subtle shifts in the operator's spin states, their intention, their focus, and actually respond to it.
Which implies we could build a machine operated entirely by human thought.
Yeah.
It's a staggering concept, and I know it sounds like pure science fiction. But if this exact shape, this 3-pronged, 120-degree triad, is theoretically perfect at stabilizing incredibly fragile quantum states like human consciousness, we really have to ask, is anyone trying to build one to fix the fragile quantum states in our actual physical hardware?
Well, that logical bridge brings us directly to the final source document on the table today.
The analysis of the silicon quantum antenna.
Exactly. This takes those massive metaphysical theories of the metallurgical document and grounds them in immediate modern technological reality.
The exact same physics apply, but just scaled down, right?
Right. Imagine taking that 3-pronged tuning fork, but instead of using neodymium or spintronic alloys, you engineer it out of pure doped silicon.
Okay.
You shrink it down to about 5 centimeters in length, and you run it at a frequency of 1 to 10 gigahertz.
Which is the standard operating frequency for modern telecommunications, like 5G networks and Wi-Fi routers.
Yep. But more importantly, it places it squarely in the arena of modern quantum computing.
Because quantum computing currently faces a massive multi-billion-dollar roadblock.
Decoherence.
Right.
A standard computer uses bits, 1s and 0s. A quantum computer uses qubits, which can be a 1, a 0, or both simultaneously.
The superposition state.
Right, which gives them exponential processing power. But qubits are notoriously fragile. The slightest environmental interference, a stray electromagnetic wave, a microscopic vibration, even a tiny fluctuation in room temperature will physically crash the qubit out of superposition.
It just decoheres back into a standard bit. Which is why, if you look at a modern quantum computer, it looks less like a laptop and more like a giant gold chandelier suspended inside a massive cryogenic freezing chamber,
Yeah, they have to supercool the processors to near absolute zero.
just to quiet down the thermal noise of the universe long enough to run a single calculation.
It is an incredibly brute force method of engineering. We're just freezing the environment to stop the noise. But the silicon quantum antenna proposes a completely different solution based entirely on triaural resonance.
How does it work?
Well, if you introduce this tiny 5 centimeter silicon fork into the quantum computer's architecture, it doesn't just block the noise, it generates that stable, rotating toroidal field.
Because it's silicon, which is a semiconductor, so it interacts differently than the metals we discussed earlier.
Exactly. It acts as an active, localized feedback loop. So when a stray wave of heat or electromagnetic interference hits the system, the triaural field reads that fluctuation, physically processes the interference through that 120-degree rotation, and broadcasts a harmonizing frequency back out. It constantly neutralizes the environment.
So instead of building a multi-million-dollar refrigerator to hide the qubits from the noise, you basically put an active noise-canceling headphone directly inside the processor.
That's a perfect way to describe it. The geometry itself becomes the stabilizer. It replaces raw cryogenic isolation with intelligent geometric harmonization.
Which would allow qubits to remain stable at much higher temperatures.
Yeah, and because we established that this geometry excels at creating macroscopic entanglement, the implications go far beyond just processing power.
Oh, the quantum internet.
Exactly. This silicon antenna could theoretically act as a secure, lossless router for a future quantum internet. It could beam entangled states over long distances without the degradation we currently see in fiber optic cables.
Because the math holds true regardless of the medium.
Right.
The exact same Bessel functions that forced acoustic waves in water to form perfect hexagons are the exact same mathematical principles forcing the electromagnetic fields to cancel out thermal noise in a quantum computer.
The physical principles scale perfectly. It really demonstrates that the geometry is fundamental.
Yeah.
The 120-degree triad is a universal mechanism for creating localized coherence, whether you're manipulating water, magnetic fields, quantum spin, or silicon semiconductors.
Which brings this entirely back to you listening to this right now. Why should you care about toroidal mirroring or spintronics or microscopic silicon antennas?
It's a valid question.
Because it fundamentally challenges the mechanical worldview we've all been taught. We are conditioned to see the universe as a collection of dead matter, just atoms bouncing into other atoms, basic cause and effect.
It's just a giant machine.
Right. But this deep dive suggests that precise geometry, combined with specific materials, doesn't just passively exist. It actively shapes the underlying quantum field.
It implies that reality is a deeply resonant, interactive medium.
It responds to shape, it responds to composition, and if the theories surrounding microtubules hold any weight at all, it responds to our own bioenergetic states and intentions.
It moves us from a universe of isolated objects to a universe of interconnected fields. Everything is continuously reading and reacting to the resonance of everything else.
And that leaves us with a truly provocative thought to mull over. We've spent this whole time looking at highly specific engineered devices, tuning forks, placed inside magnetic coils or supercooled processors. But the physics apply everywhere.
Everywhere.
If a simple physical structure of 3 prongs angled at 120 degrees can theoretically act as a localized antenna to harvest harmony, stabilize quantum states, and even interface with human consciousness, what does that say about the everyday spaces we live and work in?
Well, the physical environment you are sitting in right now is generating a resonant field based entirely on its geometry and material composition.
Exactly. For you listening, look around you. Look at the architecture of your office, your apartment, the rigid grid of the city outside.
Lots of squares.
We live in a world dominated by completely linear 90-degree right angles. We surround ourselves with synthetic materials, steel rebar, and drywall.
We engineer our spaces for structural efficiency, entirely ignoring the bioenergetic physics of the shapes themselves.
Right. So if the math shows that 120 degrees creates biological and quantum coherence, are our modern buildings and right-angled spaces inadvertently trapping us in fields of reverse resonance?
Are we spending our lives inside architecture that literally causes decoherence in our own biology?
Creating that ambient stress and brain fog we just accept as normal?
Mm-hmm.
But armed with this understanding of triaural resonance, We don't have to be passive victims of our environment.
We could actively change it.
What if we consciously redesigned our living spaces, our tools, and our cities, not just to hold a roof up, but to actively harvest coherence? It makes you look at that neat, precise binary circuit board and the room you are sitting in a completely different light.
It really does.
The universe isn't a rigid machine. It's a massive, interactive symphony. And the shapes we choose to build fundamentally change the music of reality itself. Thanks for taking this deep dive with us. Catch you next time.